8.5, Part 1, Properties of Logarithms. So we have properties of logarithms similar to the properties of exponents, and since the logarithms are the inverse of exponents, it makes sense that they should follow similar properties. So first one is the product property. So just like it sounds, we take log base b of some product, so in this case u times v, is equal to log base b of u plus log base b of v. So the product property just says that the log of a product is equal to the sum of the logs of each of the elements of that product. And we've got the quotient property, which just says that log base b of u divided by v is log base u minus log base v. So we take the difference. And then the power property says that if we take log base b of u to the nth power, so that exponent then becomes a coefficient on the front of the logarithm. So the exponent moves over here to the front, and it becomes n times log base b of u. Okay, and so now we're going to get some practice doing this. Okay, so for example 1, using the properties of logarithms, we have a couple of approximations here. So log base 3 of 4 is approximately 1.262, and log base 3 of 5 is approximately 1.465. So we're going to use that in order to approximate each of the following. So for A, we have log base 3 of 4 over 5. So we're going to use our quotient property. So we use the quotient property here for log base 3 of 4 over 5. So that's log base 3 of 4 minus log base 3 of 5, which means that we're going to take log base 4, which is approximately 1.262, and subtract log base 3 of 5, which is approximately 1.465. So on the calculator, 1.262 minus 1.465, and I get approximately negative 0.203. Okay. For B, we have log base 3 of 20. Well, that right now that doesn't match up with anything, but if I look at it in terms of 4 and 5, I notice that 20 is the product of 4 and 5, so that means that it would be log base 3 of 4 plus log base 3 of 5, which is approximately 1.262 plus 1.465, which is approximately, well, let's see, 1.262 plus 1.465, so approximately 2.727. Okay. And then C over here, log base 3 of 16. So again, I don't have it in terms of either 4 or 5, so I notice that 16 is the same as saying 4 squared. So if I use the power property, that means that I take that exponent and I put it on the front. So it becomes 2 times log base 3 of 4, which would be approximately 2 times 1.262, and 2 times 1.262 is approximately 2.524. Okay? Now the next thing that we're going to talk about is example 2, expanding a logarithmic expression. So in other words, we're going to use our properties to expand the logarithmic expression, in other words, to get it out to its base components. So I'm going to start, I have log base 4 of x squared over 3y cubed. So not only do I have a quotient there, I also have a product, and I also have exponents. So I'm going to start off with my quotient property. So that splits into log base 4 of x squared minus log base 4 of 3y cubed. Okay, then I'm going to take a look. I've got a product right here, 3 times y cubed, so I'm going to use the product property. So that would be log base 4 of x squared, nothing changes there, minus, and now I need to be really careful because I'm going to split this into a sum, so I need to make sure that I put it inside parentheses. So log base 4 of 3 plus log base 4 of y cubed. Now I have to take a look. I've got exponents, so I need to use the power property. So I've got an exponent here on the x, so I'm going to have to move that over here to the front. And I've got an exponent on y. I'm going to move that to the front of its log. So now I've got 2 log base 4 of x minus my quantity, log base 4 of 3 plus 3 log base 4 of y. And then the last thing I'm going to do is simplify, and so I will simply distribute this negative symbol into the parentheses. So 2 log base 4 of x minus log base 4 of 3 minus 3 log base 4 of y. And that takes care of 8.5 part 1, and then I'll do the next examples in 8.5 part 2.